So here's another one I thought would just be an interesting little study here. So our problem scenario on this one, looking at a gas dryer, is that you start it and it just after you start a cycle, it just goes blank. Everything shuts down, goes dark, no lights on the UI. The machine is totally dead. So it was good. It was everything was alive, and then you start it and you've lost power to everything. So looking at the circuit here, and
So
I'll
what would
start
be, yeah,
tracing it out.
Sam, what would be the load of interest there?
Yeah, yeah. If nothing is working, here I'll give you a little broader view. If nothing is working in an appliance, what's your load of interest?
Your
I
phone
would
ring.
say probably the control.
Yeah, yep. Control board would be your load here because it's the prime mover in the system. If the board's not getting power, nothing is going to do anything. So you'd analyze your circuit for your load of interest, figure out how it gets power, and if there's anything that could prevent it from getting power. And that's what we start looking at here. So we've got our plug right here. And if I just start here at line one and start tracing it in, this is just what you do. You follow things in and, oh, that's a little unusual. You've got a high limit in line before it even gets to anywhere on the board. You've got these two different places that you have lined to the board, but both of them, in order to get to either of those touch points, you have to pass through a high limit.
So this is why you look at the schematic. You don't try to go from memory. You don't try to wing it. You look at the schematic because it's your strategy planning. It gives you the overall bird's eye view of the battlefield. And it's kind of unusual to see a switch in a board's power supply, but we have that in this case.
Yep.
So,
See,
real quick,
I'm curious.
I'm sorry. I'm a little confused. Weren't we getting power and then it shuts off?
Yeah,
Yeah.
so that's what was kind of odd about this scenario. It is perhaps a flaky high limit. It's kind of intermittently failing,
I'm
but this would at
curious what
least be
that
the place
looks
that you
like too.
start.
Fail under
Did
load.
This is this a GE?
Yeah.
so? What was the symptom that the tech saw? It would work in standby as soon as you start a cycle, the UI would go blank,
So
and then if you power cycle it, would it come back on, or did they? I mean, was that a one-time thing?
No, it was a recurring thing, and the tech was working off of a customer description and had difficulty replicating the thing. So this is
Uh,
kind of a war game based off of the symptom that was being reported. So
So even
yeah,
even in this case, even if the high limit was not the ultimate causative problem, you want to at least rule it out because high
mhm,
limits do go flaky. And easy way to do that, you could jumper it out, do a jump if the jumper's easy to do, jumper past that high limit, jumper around it. It depends on how much disassembly you have to do. I like to do minimal disassembly for troubleshooting, but it's at least something to eliminate as a possibility. And
mhm,
you'd only know to even think that way by seeing it right there on the schematic.
yeah,
But
yeah.
again, like Tim said, I mean, it is getting power, so that would have to be good, correct? That high limit?
Well, switches go flaky. And so they can be good in a quiescent state, and then you start running some current through it. I mean, look at what's going through there. It's supplying power not just to the board for its own operations, but it's also supplying L1 for the heater.
Yeah, all the current for the entire operation of the unit is going through this high limit.
All your L1 current.
So it's going to be a switch that's under a lot of stress. So if it does start getting flaky, yeah, it's very possible that it will fail under load.
And you could at least this it may not be the problem, but it's something you definitely got to rule out.
Okay.
Yeah, yeah, I
And
think
I
the
guess that's a
only
key takeaway too. High limits, they typically, most commonly, we see them fail and they're done. They're open, won't reclose, but they can also fail under load. Switches can fail under load,
yeah.
especially ones that are carrying working current.
Is that one of those white ones or is it a different style?
Don't know about the style on this one.
Yeah.
Yeah,
I,
sure
I
either.
thought I actually had a blog post on this right here, something very similar under GE. It was electric dryer, but it actually had this exact scenario where it runs the L1 through this thermostat, and the thermostat that I had was charred. So it's sometimes making a connection, sometimes not. And
Oh,
I got some up close pictures of the actual charring of the thermostat of it.
Oh, I
Yeah,
did.
yeah, yeah.
I've forgotten. Let me go see if I can find that. And Sam, if you can find that, we can post that
So I
here
had
for all
pictures
to
of it in the
see.
log.
yeah, that sounds very similar to what could be going on here. It's really either going to be that high limit or some weird house wiring problem. I mean, those are the only things we've got here that could interrupt power to the main control.
I put Tim the Sam, if you want to open that, he's got some good pictures in there.
Yeah,
I'd
sure.
forgotten all about that when we were looking at this one. But yeah, you can post some of his pretty pictures.
And the customer complaint on this was intermittent flaky dryer working. And
Interesting.
by the time I got there, it was dead. And the customer had actually already like tried to take a couple things off. So I kind of walked into it when the customer had already tried to fix it. And then I was like, all right, well, let's start. And sure enough, got the tech sheet out and I was like, oh, look at that. There's a fuse right there.
Scroll down in that post too,
Yeah.
Sam. Show him
Yeah.
the crispy critters.
Yeah, so I'm just exact same type of setup, line,
Electrically the same, yeah.
high limit, and then to the board. And yeah, that's
Oh,
Yeah.
yeah. Yeah, so these are switches that are under a lot of stress
Good
and
one,
you've got a lot
Tim.
of current going through them.
It
Yeah,
looks
wow.
like it's actually shorted out though. Did that happen after?
Well, this was dead now. Yeah, I arrived and the unit was dead, but the
It
complaint was that it was, and there's the new one.
it
And
failed open. It did
yeah,
not fail close. It failed open.
right.
Yeah.
But it does look like the wires are touching though.
Yeah, I mean, I don't know it could have been. I don't know on that.
That was just posing for the camera.
Yeah.
So this fuse is react to temperature or current?
High limits are temperature controlled
Temperature, yeah.
switches. Yeah.
Yeah, this is temp. Yeah.
Yeah.
Yeah, they
In
show.
fact,
In fact, go to the schematic, Sam, and they tell you that explicitly by the symbol.
But
sure.
the interesting thing is that the fact that it's on the heating canister.
Yeah, that's right.
Yep.
Yeah.
Yeah. So we can see that on this schematic. What they're showing here is the side of the drum. So on this one, at least, you've got all these safeties kind of attached to there, feeling the heat in there.
Yeah,
But
it's that
the
back
bottom line is
wall.
that they're, yeah,
It's that back half disc that the drums fits into. In fact,
yeah,
I think if you
exactly.
slide over, you'll see it on the other
So-
pic. Yeah.
So do we have an idea of why they placed it? Scott, you said it's an unusual placement for that. Do we have an idea of
I think
potentially
it's
why they did that?
Yeah, I think it's hyper safety. You'll also see some GE dryers will have a fuse, an actual fuse in L1 that's in the very back of the dryer. Matter of fact, I've got a video at YouTube showing troubleshooting that without having to pull the whole thing. It was in a laundry cubby, so I didn't want to pull it out, but I wanted to be
Okay.
able to prove that the fuse was closed or open without having to pull it out, and I showed how to do that. And so this is like a common GE motif. You'll see that they'll put this, what I think is hyper safety stuff. It actually turns out being like troubleshooting heads up to the tech, because whenever that high limit opens, you're going to lose your display. So in
Yep.
other words, they're saying that high limit should never ever open, and if it does open, something's way wrong.
Well, yeah, and you can actually see that they give the spec for these different switches when they open and close up here. You see the high limit got to get up to 315
Yeah.
for that thing to go open. And it's higher than any of the other safeties.
Wow.
So that's kind of the weird thing about this. It's part of what makes it like seem like a really redundant safety feature is because if either of these will go open, that's those two, cuts off your heating. So you'd have to have something go really wrong for you to get such runaway heating that this high limit is the fail safe that shuts everything down.
Right, because they're figuring if it's 315 degrees, if the high limit's feeling 315 degrees, then something's way wrong. Shut it down because we're getting ready to have a fire.
But I can't even really imagine a plausible scenario where you get up to 315 and one of these hasn't gone open to cut off the heating. It's just an odd design thing. It seems like it's really not functionally doing anything for safety, and it's just
Well, it's redundant because it's like in Nav Air. One is none, two is one. Everything's redundant.
But in this case, it's a redundancy that's actually causing an issue here. You've got this high limit that's gone flaky and is now causing an issue for the entire appliance. So
Yeah,
Do
there's
you
been
think
there's been times when I go to pull off the connection off of one of those and it just crumbles, so very similar to what Tim was showing. I'm well aware of how they could just fall to pieces.
yeah. Yeah, high stress
Yeah.
lifestyle for that thing.
Tim, thanks again for the reminder on your
Yeah.
blog post and showing those pics. That was awesome.
Yeah.
Well, that was very interesting.
And last thing I'll just show on this one, just because I've got the picture here. Uh, Very easy to get to this control board. You just pop the top off and it's right up there up front, so you can do whatever testing you need very easily. Minimal disassembly. You can just check, start the cycle and then check for if you have voltage at either of these points. And if that voltage, goes away when you start the cycle, that's kind of a dead giveaway that you've got a problem with the high limit there.
And you're checking the voltage with one of your probes on one of the red lines that you mentioned. Your other probe will be on CN11 pin 2.
Yep. So let's just say there, and then, yeah, over here to
Is
neutral.
that neutral?
Yep.
Yep.
Okay.
Yeah, I can draw in neutral to make that clear.
Could I ask a question there, lads?
Yeah.
If the high limit was gone and burned like that, and you changed the high limit, should you change any other stat inside in it as well? The fact that the high limit got so hot, would the other ones be maybe need to be something done with them as well at the same time?
That's an excellent question. I would not only do that. I mean, you're right there. These switches aren't that expensive. You're not adding a whole lot to the job. You're adding value, but also check your airflow. If you got high limits opening, you want to always check your airflow. It could be dryer kinked or caught up in the screen at the outside. I mean, you can do the calibrated palm test on the exhaust pressure, but yeah, so yeah, good question.
Yeah, and because as you can see here, they're all in exactly the same neighborhood. If you're getting to the high limit, you have access to the other controls, so no reason to not just change everything.
I have seen those thermostats from GE be quite expensive. On some of them I have seen. I mean, like, I don't know, like $45 for one of those little things. I think
Some of the
three of them.
manufacturers, like Whirlpool, they'll even sell them as a whole kit. I mean, you just get all of them in one part number kit. The intention being that that's exactly what you do is you replace all those controls if one of them goes bad.
Yeah, and that's what I would say to that. Even if they are a little on the expensive side, they shouldn't be. These are little cheapo parts, but even if they are gouging you for them, you're giving the customer a better, much more reliable repair if you change all of them. Because if you just change the high limit and leave the others, you're leaving yourself open for a callback.
After you check your airflow.
Yeah.
Yeah, so on this one, was it like the thermostat failed of its own volition? There wasn't something else that caused it?
Not that the guy said in the post, so we don't know.
Yeah, and keep in mind what you saw, like in Tim's pictures, how it was all burned up. In this case here, now it's passing L1, it's just a gas burner, but you'll have some where they're electric and you're passing L1 current through for an electric heating element. Well, that's significantly more amps. And it's those amps passing through it that can burn it up. Not the heat from the canister that it's feeling, but it's actually having to pass a lot of amps.
Yeah, like
Tim,
in
was yours
Tim's case,
gas or electric?
This was electric.
Okay, so yeah,
It's
you're
electric.
passing some serious amps on this one.
Yeah. So in Tim's case, that's
Like
absolutely what it
23
is.
amps or something.
Yeah.
It's the amps that burned this up, not the heat from the heater.
Well, and then we also have vibrations and poor contacts.
Yeah. Yeah.
Yeah.
Yep. And
Yeah,
poor
loose
contacts
connections
on
will make
terminals.
heat.
Yep.
This makes me think of a question, Scott. I've heard you say in a video before that electricity, like the electrons, flowing through, like take wires, for example, like wires don't really wear out. I mean, unless you have like a bad connection. So would you say with all the amps going through this, like for Tim's, would you say that was because of the amps, or was it because of the amps combined with maybe like a poor connection or something?
Well, the amps combined with a poor connection is what's going to give you your heat. Sometimes it can be an internal thing. It's not even one of your external terminals that are loose. It could be internal, something that's failed internally where now suddenly, closed switch, we always say closed switch should be like a piece of wire. I mean, technically it's like a tenth of an ohm or something like that. We don't worry about that for troubleshooting. We call it a piece of wire. Well, you start getting 1 ohm, 2, 3, 4 ohms. It doesn't take much, especially at 23 amps. You're dropping significant voltage across that, and you're producing feelable heat. Enough heat to do damage like this.
Well, I actually think it's the combination of both the heat from the element as well as the amps going through. I think because that part it brittles up over time, I would think. So between that getting dried out and stuff and the heat, the amount of amps going through there, again, it's just my observation that it could be both that are causing that.
Could be. And in this case, though, it was the high limit and not like the safety or one of the other bimetals that went out. And you'd think if it was combination of heat and amps that one of those would have gone too, or instead
True.
of.
True.
And we can't discount manufacturer errors. And a good example would be the GE dryer with the heating element on the back wall that the purple wire always burns off at the terminal. And they've changed that now to where they actually have a replacement wire for that that's a different gauge wire, and you now actually have to depin it from the connector at the motor and put that new one in there. And so that's from the manufacturer, so they made mistakes. So we can't discount stuff like that. And then back to the airflow. So I think I have another blog post, interesting enough, about a Bosch dryer that has Bosch dryers have the reset thermal fuses on them. And you can reset it and you can replace that thermal fuse all you want. But unless in my case, it actually had so much lint buildup on the heating element, it wasn't drafting air through it. And unless you clean that out, you're just going to keep coming back on that call forever. So sometimes it's actually not the part, it's not the wires, it's airflow. So all of these are all different scenarios. You can't just say the one was, hey, this is amps or this is heat. There's many different reasons why these things can fail. Sometimes they're just cheap parts. Like Scott said, these are cheap parts. They could just be cheap parts.
I had troubles with a Bosch dryer one time, and I took it apart and it couldn't figure out anything, and it ended up being the lint trap.
Yeah.
With fine lint.
Yeah,
That'll affect
like
airflow.
that.
Yeah.
Frigidaire, they have a service bulletin. They changed out the lint screen on one of their dryers because it was so fine that it was not drafting the air through it and it was causing problems.
And Tim, that's an interesting point you made with the gauge of the wire, and they went to a larger gauge. So wire has a certain ampacity. And so if you're, in other words, the ability to carry amps without, safely. And if the gauge of the wire is too small, or, if the diameter of the wire is too small, the gauge number actually goes up. But if that diameter is too small for the amps that it's supposed to carry, that wire will start generating heat, and you start doing things like melting conductors in extreme cases, or just creating heat at the connections.
Yep.
And that can be another fail point. Good stuff, guys.